A Doooovid here in Metro Detroit at the Automotive Advanced Manufacturing Expo. Been coming to this for years. Bigger this year. We have looks like a kids competition, robotics competition added to it. Create some excitement. I've had the winners of it at previous years. I've been hoping to go live, but unfortunately I used up all my data. So I have the 1,000 subscribers and now capable of live streaming, but I used up my 8 gigabytes of data, which seems like a lot, but for high definition recording, 8 gigabytes goes extremely quickly. So I switched to unlimited data plan, but that doesn't take effect till the beginning of September. So have to just record it. So pretty cool. Sees quite a few teams. Robotics challenge. I'm more a straight nerd, straight autist. Yeah, I prefer technology for technology's sake, science for science sake. But for the kids, they try to make it more interesting by having these competitions, robot building competitions, usually simple tasks like picking up a ball and throwing it. You program simple basic physics, such as projectile motion. And so these competitions are pretty popular. I think they're on TV and everything. So this year they have the actual competition here at the show. You see all the teams last minute putting their robots together, preparing for the competition. Pretty cool. Troy, a lot of high schools. And then you got bleachers, I guess. I don't know if there's any actual fans to this, or all these people are friends and family of the team, or if people would actually have came to. Okay, so I might come back to that. Yeah, we'll have the battery show coming up. Hey, God bless. Very good. Battery show coming up at the beginning of September. The Automotive Testing Expo. They've expanded the test center, the Expo Center here. So this is a pretty big show, not one of their biggest shows. So I'm going to walk around, see what kind of companies they have, and I'll probably go around, pick up some reading material. Interesting technology demonstrations. So they have a few different sections: metalworking, automation. So I have some latest robotics on display. It's a simple device, probably picks up pens and rulers and gives them away to people, but the robotic arms, automation. So automation is a very important topic these days. But for people who want an insider look at how automation works, how that is used to facilitate manufacture, these are the experts. I've been coming to this for years to keep on top of the latest developments. And I know most of these companies. Like, I've been coming to these for years, so I've spoken to a lot of these people, the same people, year after year, although there's always new companies coming. This one's more an American. Hey, good to see you. This one's more an American one. You know, like the battery show, others will have more manufacturers from around the world. So this show focuses majority American companies, although presumably they have international counterparts. It's just the global supply chain, the way it works. So you have a variety of companies selling products that facilitate manufacture engines, motors, consulting, materials, engineering, even some financial service components, and so you got a relatively big device on display. Here's your simple robot arm, trainable robot arm, I think, where you could move it with your own hand and train it to... Oh, yeah, please. I'll come back if I can. Thank you. I'm just going to walk around. Usually I go and try to cover all of the tables, speak to some people, get some of the devices, reading materials. So first I just want to take the camera on, talk. I guess they got teams going on. So I'm going to try to make it through all the aisles, see what's going on, the different major companies, what they're selling, what's new, it's tables, support. So if you were creating a manufacturing facility, or likely you were already in the manufacturing business, and they try to put together all the companies that would be necessary to advance your manufacturing abilities, capabilities, such as suppliers, robotic dealers, consultants, engineers, all different types of devices, from components, electronics, computer software, measurement facilities, drill bits. Hey, good to see you. Drill bits, sensors, computer packages. So, and this conference actually travels across the United States. So I've seen this display in the past, all the various different types of sensors. So as the manufacturing process becomes more automatized, sensors become more and more important. That's how the computer understands what's going on. So you have a lot of companies that specialize in sensors, RFID, radio sensors, your various robotic arms. Sometimes they talk about degrees of movement, how many various degrees of movement. Fellow yarmulke wearer. If you have simple robotic arms, probably all cost at least thousands of dollars, to complicated robotic arms that might cost millions. It depends on the weight factor, the degree of freedom, automation in terms of artificial intelligence, machine learning that could be used for picking up devices, finding devices. You got 3D printers. I don't know if they have metal filament 3D printers. This is probably a scanning device on top of a robotic arm. So any of the various things, whether it's actually part of the manufacturing process, where the robotic arm is fulfilling a manufacturing function, or a sensory function, a testing function, configuration function. So it's all possible. So if you had endless finances, you might be able to completely digitize, automatize the process from start of material till finished product, using various robotic components at each step in order to move it forward. But most of the places, in the automotive industry, I think almost half of manufacture worldwide is automotive. So, for manufacturing, the automotive is pretty much the testing level for manufacturing processes. So you have your actual finished car manufacturers that put together the final car. They have your tier 1, tier 2, tier 3 suppliers. And there's thousands, probably tens of thousands of different components that go into automobile, and you could be any level manufacturer of just making a nice widget that goes together for the final automobile product. There you go, boss. So if you were a small manufacturer who was just making one product, historically you might have had a die stamp. There's what's called detractive, where you take a larger piece of material and cut away to get your final piece, or additive, like 3D printing, where you start from smaller parts and build up to the part. But either way, how you go about manufacture to get the widget, if you're starting with the material to the finished product, that there's multiple processes. I went to a company, I think it was Monroe Consulting, but various, breaking down manufacturing processes into individual components, and then trying to make them more efficient or quicker or less material, more cost effective, or whatever. So manufacturing process could be broken down into steps, like a flow chart of one thing, next thing, in the process of the material till the final. We got dancing. Get some dancing. So engineering, future engineering, math geeks. So a new facility that is making state-of-the-art mass production might be able to largely automatize the whole process. Although still you usually have humans. For a smaller manufacturing place, it might be largely humans with just a few robotic arms added on, possibly for the more heavy parts to speed up certain parts, or the extremely repetitive parts. So automation takes a long time. You could look at a manufacturing line. So if there were one of these consulting businesses here that was trying to help someone automate their production line, they might look at the process and so take the low-hanging fruit, or start with certain aspects that were most cost-effective or easiest to automatize, and that might be based on labor cost, on weight, on time, bottlenecks, logistic concerns, why that you might choose to automatize certain parts. So if you're looking, let's say, a robotic arm, and they could usually be pneumatic, which is air pressure, or electric, usually not gas powered. Most robots aren't gas powered, or unless it's a generator. So they're electric or pneumatic. So some robotic arms that aren't pneumatic, that don't require like an air tank, you could just plug in, and you could manually train it with your hand, where you basically take your hand, take the robot, show it what you want it to do, and then it'll keep on repeating the same process. So if you have a widget that is going through the production process, finishes one part, and then needs to be transferred to the next production unit, you could mechanically train a robotic arm to pick up a piece in the same spot and carry it to the next spot. If it was an exact repetitive movement, where it was the exact same movement again and again. However, if it was more complicated and had so if it had something that required a certain level of programming or machine intelligence, where let's say the piece may not be coming from the exact same place or going to the exact same place, it required a certain level of intelligence to place it in where it's going, you might need an embedded camera, an embedded sensor, and some sort of computer program that would be able to tell the computer, where to put it in a stack if it's stacking something, that there's already something there, and that actually could involve artificial intelligence or machine learning. And you have what's called camera-guided placers, where you could embed sensors or cameras, and then based on the camera input, the robot would be able to determine where the best placement of the piece is. So all that stuff is involved here, and so these games are largely, I don't know, I guess it gets people interested in the field, but as I said, the main thing is automotive manufacture. Over 50% of all manufacturers automotive, because most people have a car, want a car, or multiple cars, and they're a huge device that require substantial amounts of components. Although maybe like a house or apartments or something like that doesn't have so much technical material that requires robotics. So obviously there's appliances, there's many other parts of manufacture that aren't automotive, but in terms of the size of the business, automotive makes up over 50% of all manufacture. So things like microwaves, refrigerators, washing machines, industrial equipment, printers, computers, all are huge sectors, but compared to the automobile, so in terms of robotics, they'll sometimes use the expression automotive or bust, because if you have a product and you want to sell it and you can get it into the automotive industry, you have pretty good chances of success of economic viability, as opposed to looking for a smaller sector. If you just had a component that only worked for, say, one device, like radios or printers or something like that, you could have success with it. But if things change, so generally automotive robotics manufacture steers towards automotive. So I'm not sure. Try to get a little bit of one of these competitions if they get these guys going. So I'm more a technical geek, not so much into games, and generally would tear towards robotics that serves some utilitive purpose. But for educational, these games, as say, usually shooting projectiles or playing some sort of sports are what's most popular. So let me see if I could look at some exact robotic arms. So here's, I don't know if this has machine learning or it's going around, and sometimes they have stuff that could give people like bottles of soda. They could just have sensors attached so it doesn't bump into anything without any machine learning. But there you got, picking up the Snickers, bring it over to their bar, and then I might drive around and give it out to people. So it's just a pretty simple demonstration. And as said, this is for trainable. It's the exact same movement. It does again and again, and then the conveyor belt will put the next Snickers into the exact location. So I was talking about machine learning. This is something where the robotic arm could have had an exact training of a very specific movement. It's just doing the exact same movement again and again. It doesn't require any sensors or artificial intelligence, because it's just picking up the piece at the exact same place each time. Although you see here, it's not placing them in the same place. So it could be a program that's trained it to pick up a certain amount and put it in certain places, or a program that would have been more complicated, like a machine learning that would require some sort of computer intelligence to map out the given space, determine what's there, and then intelligently place the material. So my guess is this is probably pre-programmed and doesn't involve machine learning or artificial intelligence, but that would be an example of a difference between machine learning, artificial intelligence, and just programming, where the person programmed to pick up 10 Snickers, place them at these given different points, or if the computer actually had an embedded camera or sensor, and from there determine on its own where to place the pieces. So more advanced facilities would have machine learning, more embedded sensors. So I walked around, you had a bunch of these sensors on display here. So here's another demonstration setup. Looks like they got pens and rulers. Bigger piece on a embedded belt going, picking up a pen, dropping it, handing it, a direct handoff to another robot, and then the robot potentially sticking it in a grid that a person could take it. And this also, I'm not sure if it has an embedded camera, so if the computer is programmed, this one might actually have an embedded camera that would be programmed to use some sort of sensor to determine where the piece is. And it looks like it's programmable. So there might be an embedded camera where the camera determines where there's a piece that could pick it up. Because so it looks like they have the control device. So this is Alan Bradley, which is part of Johnson Controls. I go to the Siemens conference, so Johnson Controls for building automation's a direct competitor with Siemens in these control systems. So they have a nice display of because this is more American. So Johnson Controls is American competitor to Siemens, which is a popular German company. So I don't know if they have one of these teams coming. Let me see if I look at a few more displays. But that would be an example of a minor form of machine learning, where you could have an embedded camera in a program that is designed to look for a certain piece, use the coordinate movement of the X, Y, and Z axis in order to locate the piece, and have a gripper that would go down. So there's quite a few let alone a complete automatized production line like they might have in advanced manufacturing facilities, where they might have hundreds of robotic arms that complete a car component or assemble cars based on units. So here they have metal working, transmissions, and I'll probably go by and pick things up, try to see what all these are, get the latest reading material. Various metal manufacturers, electronic components, snap together manufacture pieces that hold like drill bits or various tools that go in the head of machine arms. So different machine arms have plug and play, somewhat like a computer, where you have some sort of, you would just get a generic robotic arm, and depending on the robotic arm, whether it's designed for manual training, computer training, or connected to a certain type of software that requires either like a Siemens mechanical control device, like a PLC device, or that would go into some sort of computer. So, but once you got one of those arms, and you could have various, like here's just a simple XYZ, axis where this only has 1 degree of motion, or your 3 degrees where you could have X, Y, and Z versus robotic arm that twists. There's various places it could move or twist to reach different things. And then at the end, it has like an open frame that you would be able to attach different things to, suction cup, magnet, clippers, or various type devices that would attach onto the end. So, there's all the, various things, kind of like, these old school drill bits or mechanical devices or battery power. And let's say the motor just spins, and it could be, screwdriver, a drill bit, sander, or any various thing that might use a spin device. The old school, simple, this just has an XY platform where, one thing moves one way, and then the smaller thing moves, the vertical and horizontal versus a lifting device. So you could have your simple XYZ that doesn't have a robotic arm. It has a mounted device. Data logic, sensors, Siemens partner, scanners, all different type devices. I'm probably not gonna, this video is largely for myself. I've been going to these for years, taking pictures. So I would have liked to stream this and, show all these various things. Here's ignition, solutions, design. Dynamics, control systems, the different software. So I'm not sure if this has a intelligence program. So here you can see it has a video of the pieces, and then an arm that has, it looks like 3 degrees of movement, 2 arms that bend, and then one that has circular movement, and probably through a embedded sensor. So I don't know if this would technically classify as artificial intelligence or machine learning. That so it has a gyrator to move them around. So I don't know why some of them are green or red, but I mean, you can see that it kind of figures out what piece it's going to get to, and then will chart out an arm movement strategy. So it returns to basically the same initial position each time, and then it'll pick upon a piece that it wants to pick up, and then it'll drop it off in the box. But each time it returns to the position and will decide what it's going to do before it does it. So there's some sort of device, embedded camera on top that you can see, and the computer program will look at which one of these switch it wants to pick up. It'll chart out a pattern, and then it'll do it, pick up the switch, and place it in the device. So these are just simple displays. It's another simple display. Very good. So just returning. That one's also probably programmed just to 4 and 4. This is actually a sensor. So on top of this arm is a 3D sensor that would be scanning a piece. But you could place different things. Kawasaki, Japanese manufacturer, one of the bigger robotic arms makers. Okay, so let me see if I get one of these competitions on this. I'm not sure what the holdup is. So, see if they're going to get one of these teams up here.
Yeah, raise your hand if you like that video. Did anybody know Derek Coleman was deaf? Did anybody know that? Yeah, I didn't know that until I saw this commercial. So that just goes to show, if they tell you you can't build that robot, You built that robot. All right, so let's take a look. All right, raise your hand if you've ever seen a movie on Netflix, in the theaters. Raise your hand if you've ever, has nobody seen a movie? Raise your hand if you've seen a movie. All right, here we go. You guys want to play a little game? All right, here's the thing. Students, you don't find out advantage in the beginning. So we're going to see, so you need to try to represent. So don't bother eating lunch right now. I don't know if you can see the number or not. Here's what I'm going to do. I have a picture of a movie. I'm going to put it up on the screen. If you think you know what that movie is, I want you to yell out your title. You guys got that? All right, here we go. We'll start with okay. Here comes the very first movie. All right, adults, if you like movies, you might have an advantage right there. Here we go. What movie is this?
Okay. Yes, I'm probably not going to wait for this competition. I'm going to go around, take some pictures, grab some reading material. So hopefully this is useful. If people watch this, I hope they gain from it, learn some insight in the basic automation process, the different companies that are involved in automation, and see the competition. So I'm going to go table to table now and collect some of the reading material.